morning and welcome to Biology. I'm Paul Suchecki and this is my classroom. It's great to see all your smiling faces back for another biology lesson. Today's topic is homeostasis, diffusion, and osmosis. The universe is not always a hospitable place for living things. Cells go to great lengths to maintain order in a world where disorder seems to be the rule, if you know what I mean. Only within this little bubble that we call Earth, where our atmosphere protects us from the harshness of space, is life even possible. The challenge that cells face is maintaining an internal environment where metabolism is possible. Metabolism occurs under very strict conditions. The temperature, solute concentrations, pH levels, and a host of other conditions have to be just right for these life-sustaining processes to continue. Homeostasis is an internal biological balance, or a constant internal environment. No matter what the conditions are outside, hot, cold, wet, dry, your internal environment has to stay balanced and relatively constant. For example, your body temperature is probably close to 98.6 degrees Fahrenheit. That's the temperature at which your metabolism works the best. Your body goes to great lengths to maintain that temperature. Your body temperature can go up and down a little bit, but if it goes too high or too low, that could be dangerous. Fortunately, you have built-in mechanisms that help keep your body temperature close to 98.6. For example, let's say you're out on a hot summer day and you're working real hard and your body temperature starts to go up. If it goes up too high, that could be bad. We call that hyperthermia or heat stroke. Fortunately, when your body temperature starts to go above 98.6, you start to sweat. By sweating, that cools your body down. As the liquid sweat evaporates from your skin, it takes with it excess heat, leaving your skin just a little bit cooler. So once your body temperature drops back down to 98.6, you stop sweating. It's called a positive feedback loop. The hotter you get, the more you sweat. The more you sweat, the cooler you get. You can't help it. It's automatic. On the other hand, let's say it's a cold January morning, and you go outside without a warm coat. Your body will start to lose heat to the environment, and your temperature will go down. If you get too cold, we call that hypothermia, and that could be dangerous. Hyper means too much. Hypo means too little. So if your body temperature goes below 98.6, you have an internal mechanism to help warm it back up. You start to shiver. By shivering, your muscles become more active and start to generate heat. So once your body temperature is back up to 98.6, you stop shivering. Again, it's a positive feedback loop. The colder you get, the more you shiver. The more you shiver, the warmer you get. You can't help it. It's automatic. Another example of homeostasis has to do with your body fluids and hydration. According to homeostasis, there should be the right amount of fluid in your body. Not too much, not too little. If your body fluids get too low, that could lead to dehydration. If your body fluids are too high, you could be overhydrated. So let's say you're outside on a hot summer day and you're doing work, and your body's getting hot and you're sweating. The more you sweat, the more fluid you lose. So as your cells and tissues become dehydrated, they send a signal to your brain. It's kind of like, hey, send some water down here. And your brain sends a signal to your mouth and you feel thirsty. When you feel thirsty, if you have enough sense, you'll go get a drink. It's your body's way of telling you you're getting dehydrated. So when you get a drink, that replaces the water you've lost, and now you're rehydrated. Even my dog has enough sense that when he's thirsty, he gets a drink. But let's say you drink too much water and you get overhydrated. If you're a little overhydrated, no problem. Your kidneys just work a little harder, remove that excess fluid from your body, and then you gotta go pee. Another example of homeostasis is your blood sugar. Your blood sugar needs to be balanced. There should be the right amount of sugar in your blood at all times. You don't want too much sugar in your blood, and you definitely don't want too little sugar in your blood. If you have too much sugar in your blood, that's called hyperglycemia. If your blood sugar drops too low, that's called hypoglycemia. Let's say you're kind of a health food nut, and for lunch you had some cake and some cookies and some ice cream and some candy and some soda pop. You know, health food. What do you think that's going to do to your blood sugar level? Yeah, sky high. Hopefully you don't eat like that though. Even after a healthy meal, your blood sugar is going to rise a little bit. If everything works normally, your pancreas should release a substance called insulin into your blood. Insulin is a chemical that causes all of your other cells to start absorbing sugar. This brings your blood sugar down. My grandmother had diabetes, which means her pancreas had a hard time producing insulin. So every day she would have to check her blood sugar. Depending on the amount of sugar in her blood, that would determine how much insulin she would have to inject into her own body. On the other hand, what if you skipped breakfast? Oh, by the way, breakfast is the most important meal of the day. Don't skip breakfast. And then let's say you skip lunch. What do you suppose is going to happen to your blood sugar then? Yeah, you guessed it. Your blood sugar is going to start to drop. If you don't supply your body with food, your blood sugar could drop. Fortunately, you keep a little reserve sugar in your liver, just in case. Between meals, when your blood sugar starts to drop a little bit, your body produces another chemical called glucagon. Glucagon is kind of like the opposite of insulin. Glucagon goes to your liver and causes your liver cells to release some of the sugar into your blood, raising your blood sugar. So if your blood sugar goes too high, you produce insulin, which brings it down. If your blood sugar goes too low, you produce glucagon, which brings it up. And it's a constant balancing act. Your body's trying to keep your blood sugar at just the right level. That's homeostasis, an internal biological balance. There are many, many other examples of homeostasis, but we need to move on. One way that your body maintains homeostasis is through a process called diffusion. Diffusion is the movement of molecules from an area of high concentration toward an area of lower concentration. In other words, diffusion is the spreading out of molecules. It's kind of like if you put a drop of food coloring in some water. Over time, the molecules of food coloring will spread out through the water. That's diffusion. Yeah, but what does that have to do with living things? Let's say this is a cell in your body. In that cell, there's a low amount of oxygen, but in a tiny blood vessel right next to it, there's a high amount of oxygen. According to diffusion, molecules move from an area of high concentration toward an area of lower concentration. The oxygen will move from your blood into your cells, from high concentration to low. It's kind of like downhill. At the same time, there's a higher concentration of carbon dioxide inside your cells compared to in your blood. So again, by diffusion, carbon dioxide is going to move out of the cell and into the blood. The diffusion of oxygen into your cells and carbon dioxide out of your cells is going on right now. It's a constant process, trying to maintain the right amount of oxygen and carbon dioxide, trying to maintain homeostasis in your cells. Now let's say we go outside and start jogging. This puts an oxygen demand on your cells, and the amount of oxygen in your cells is going to start to drop. At the same time, you're going to produce more carbon dioxide. Now your cells are out of homeostasis. Fortunately, you have a built-in mechanism to bring it back into homeostasis. You start to breathe deeper and more often. Yeah, by breathing deeper and more often, you're putting more oxygen into your blood, which puts more oxygen into your cells. This also removes carbon dioxide from your blood, which removes carbon dioxide from your cells, which brings you back into homeostasis. Voila! Osmosis is the diffusion of water. Osmosis is when water molecules move from an area of high concentration toward an area of lower concentration. Osmosis is just a special kind of diffusion. Diffusion is the movement of any molecules from high concentration to low. Osmosis is specifically the movement of water molecules from high concentration to low. For example, this is a drawing of a cell. I'll even label it cell, just in case. We'll say it's a blood cell. How about a red blood cell? Just to make things simple, let's say the cytoplasm in this red blood cell is about 99% water and about 1% solute, or dissolved materials. And let's say we take this red blood cell and drop it in a beaker with a solution of, how about 80% water and 20% solute? That's pretty concentrated. This concentrated type of solution is known as hypertonic. Hyper, too much. Tonic, dissolved stuff. Hypertonic, too much dissolved stuff. Remember, the cell membrane is selectively permeable. In this case, water can move through the membrane, but the solutes can't. Since there's a higher concentration of water inside the cell and a lower concentration of water outside the cell, water's going to move. Which way is the water going to move? Osmosis says that water's going to move from an area of higher concentration toward an area of lower concentration. Downhill. So in this case, water's going to move out of the cell and into the beaker. The cell's going to lose water and shrivel up. This is known as plasmolysis. When a normal red blood cell is placed in a hypertonic solution, it will lose water and shrivel up. It's kind of like if you were stranded in the middle of the ocean and the only water you could drink was salt water. That wouldn't quench your thirst. It would cause your cells to lose water. You'd become more dehydrated and even more thirsty. Drinking salt water does not quench your thirst. That's osmosis. Now, let's take a look at the second red blood cell, number B. Again, the red blood cell is approximately 99% water and about 1% dissolved stuff, solute. But this time, we're going to take this red blood cell and put it in a beaker of pure distilled water. 100% water, 0% solute. This type of solution is known as hypotonic. Hypo means too little. Hypotonic, too little dissolved stuff. Again, the membrane is selectively permeable. The water will move through the membrane. 100 is higher than 99. So water is going to move from the beaker into the cell. The cell will gain water. This puts pressure on the cell membrane and could cause the cell to burst. Cell bursting is known as cytolysis. When a normal red blood cell is placed in a hypotonic solution, it will gain water and burst. Let's say you get a minor cut and some blood gets on your clothes. If those blood cells dry, it'll form a permanent stain on the clothes. So before the blood cells dry, soak it in cold water. The cold water is a hypotonic solution. The red blood cells absorb the water and they burst, so they don't fix to the fabric. So far, so good? Good. Let's look at number C. Just like the first two examples, we're going to take a red blood cell that's about 99% water and 1% solute. But this time, we're going to put it in a beaker with a solution that's about 99% water and 1% solute. A solution that has an equal solute concentration as the cell is called isotonic. Iso means same on both sides. Since there's the same amount of water and solute concentration on both sides of the membrane, which way will the water move? Will the water move into the cell? Will the water move out of the cell? As a matter of fact, water moves into and out of the cell at equal rates. The net result is the cell really doesn't change. We call that dynamic equilibrium. Now, the size of the cell doesn't really change, but to say that water doesn't move through the membrane isn't true. Water does move through the membrane. It's just that it moves across the membrane in both directions equally. That's why it's dynamic equilibrium. Sometimes when a person's in the hospital, they have to receive an IV. That is, they inject liquid into the person's blood vessels. This liquid has to be isotonic compared to the patient's blood cells. If the IV liquid is hypertonic, the patient will become dehydrated and very thirsty. If the IV liquid is hypotonic, then the patient will become overhydrated and their kidneys will have to remove the excess fluid. Cells are busy places, and lots of things are coming and going. Many substances other than water pass through the membrane, and the membrane has strict control over what comes in and what goes out. It's all about maintaining a constant internal environment, homeostasis. So how does the cell membrane control what goes in and what comes out? Diffusion and osmosis are both examples of passive transport. In passive transport, the molecules always move from high concentration to low. Think of it like moving downhill. The cell doesn't have to exert itself. It doesn't have to spend any energy. It's kind of like coasting a bicycle downhill. You don't even have to pedal. Gravity does all the work. It's easy. That's passive transport. Another type of passive transport is called facilitated diffusion. In facilitated diffusion, larger molecules are moved across the membrane. This requires a protein carrier that's embedded on the cell membrane. It's kind of like a helper. To facilitate means to help. Larger molecules like glucose and amino acids need help getting across the membrane. Now, the molecules still move from high concentration to low, and the cell really doesn't need to spend any energy, so facilitated diffusion is still passive transport. Active transport is a process by which cells move molecules from low concentration to high, uphill. This is much harder, and it requires an input of energy by the cell. It's kind of like riding your bicycle uphill. It takes a lot more energy. For example, there's usually a low amount of sodium inside of a cell compared to outside. So left up to regular old diffusion, sodium is going to want to move into the cell from high concentration to low. But the cell has all the sodium it needs, and it doesn't need any more. So on the membrane, there's a protein that moves the sodium out of the cell from low concentration to high. That's uphill. That takes energy. At the same time, there's a high amount of potassium in the cell compared to outside of the cell. So the same protein that pumps the sodium out of the cell from low concentration to high pumps potassium into the cell from low concentration to high. Again, uphill. This is known as the sodium-potassium pump. It's happening in your body right now, and it takes an enormous amount of energy. About 2/3 of all the calories that you consume fuel the sodium-potassium pump. It must be pretty important. What your body's trying to do is maintain the right balance of sodium and potassium inside and outside of your cells. Sometimes cells take in a large amount of material all at once. This is known as endocytosis. Endocytosis requires energy, so it's another type of active transport. When one cell eats another cell, that's known as phagocytosis, or cell eating. For example, a white blood cell in your body looks for bacteria. When it finds that bacteria, it engulfs it, it ingests it, and then it digests it. Sometimes cells take a big gulp of water. Cell drinking is another example of endocytosis, known as Pinocytosis. Sometimes cells need to get rid of large amounts of material. They need to take out the trash. When cells get rid of large amounts of material, it's known as exocytosis. They package the waste in a vesicle. The vesicle floats over to the edge of the cell. When the vesicle membrane contacts the cell membrane, the membrane breaks down and the materials exit the cell. And then the vesicle membrane becomes part of the cell membrane. Cells lead such interesting lives. You know, kind of like teenagers. Cells are pretty high maintenance. It takes a lot of effort to maintain homeostasis. But if the cell can't control what comes in and goes out, then homeostasis is quickly lost. And the ideal conditions for metabolism, they kind of go away, and metabolism either slows down or just stops altogether. A cell has a lot to do, just to stay in balance, just to maintain homeostasis. It's a difficult task, staying alive, but nature finds a way. Nature's found millions of ways. Each species is a unique solution to the challenges of life. So anyway, that's about all for today, so I think I'm going to leave it there for now. Thanks for joining in. Until next time, don't get lost, okay? Have a great day. See you then.